See, we have already completed our two of the EDA part, EDA 1 and EDA 2. That is Exploratory Data Analysis part 1 and part 2 has done. We have discussed about the basics, and further in-depth we went in the EDA 2. And right now in the EDA 3, we are going to cover about the types of analysis, right? Types of analysis. Okay, so before starting this video, we will just have a little bit of glance, a short glance on the rest of the things what we have learned yesterday or today, like yesterday and in the EDA 1 session, right? See, today topic starts at the page 23, but rest of the things we discuss what are the types of data. I'll make it start from the zero only. See, EDA, why EDA is necessary, what is EDA, why EDA is important, visualization, what is data sourcing, data cleaning. Then today topic starts from univariate analysis with visualization, right? Then bivariate with visualization, then derived matrices. Then the fifth one is the use cases. Okay, what are the use cases of the EDA? And these are the steps which are involved in EDA, right? So we discussed where the data is being collected, what is data processing, then what is cleaning of the data, then why EDA is important, right? And what is the definition of EDA? We discussed some example of HOD and the semester 4 students. Then visualization, okay, how we can represent any numerical data to the visual effects so that we can get a lot of meaningful insights of the data. Then we went to steps involved in EDA. The first step is data sourcing, where we collect the data, data cleaning, where we clean the data, categorical analysis key. Definitely many of the data will be in the category like a person is having good grade or not, like if he is having grade, so in what scale, A, B, C, or A plus, B plus, C plus. So that is categorical data. So we have to do the analysis of that data also. So we need to do a number of steps to encode it to the numerical so that it is easy to do. Then we have numerical analysis, the numerical values ki age, weight, or something like that. Then derived matrices or metrics is nothing but ki, okay, we have all this data. Now what this data comes to the output, or can we like correlate this with another data, like one column with another column to get a third thing. Let's say we can correlate, we can add age with height. As the height, as the age increases, mostly height increases in the most of the scenarios. And we also saw that my pen was making some problem. So this is the another analysis we did yesterday. So right now we'll focus on the rest of the part, that is this only, derived metrics and types of analysis. Data sourcing, there are two types of data available, that is public data, private data. Public means that is easily to available, you don't need any permission to do the data analysis part, but for the private you need the permission. Then in the data cleaning we have to handle the missing values, standardization of the data, outlier treatment, handle invalid values. See, I have already taught this all the concept in the last video, so better check that video out before starting this video. And before starting that video, EDA 2, you have to go through the EDA 1 so that you get a clarity. And before doing EDA, you should know NumPy, Pandas, and Matplotlib. So better start this series from the basics, then only you will able to get the concept at the good level. Right, then we have okay, like in what aspect we want the data to be. See, if I want only the age and height relation, I don't want the salary thing in my data, so I have to drop that. So it depends how or in what the question is, so that you can do the analysis on that question. If somebody asks the age of what is the average age in this data, but you are giving no, the salary of the person with the highest age is this, so this is not the correct thing. So first we go for the question, then we ask the key, okay, how the data should look like for a person. Then some questions you need to ask yourself about the data before cleaning the data. It's fine. Then handling missing values, delete the rows, replace it with mean, median, mode. Algorithm imputation, there are many algorithms which do it by their own, so you don't need to explicitly call them, like explicitly remove the outlier before training. Some of them are KNN, bias, random forest. Then predicting the missing values. To predict the missing values, what we have, we will train on the train the model on the values what we already have. Let's say we are already having 70% of the correct data, but 30% of the missing data. What we do, we will train our model on this 70% of the data. Then we will try to predict the column features or that values which are missing in a particular column. So it's, yeah, definitely we can train it. So this is one way of predicting the missing values. After predicting the missing values, train on both and again test for some else. So yeah, this is one way. Then we talk about categorical data and numerical data. Then standardization, feature scaling. So this is a big topic. So the small point is key computer or our system, what it does, no, it gives priority to the values which are more in numbers. For example, 110. So this is at the hundreds digit, but 10 is at 10th digit only. So our model will be biased towards the larger numbers as compared to the smaller number. So to avoid this kind of conflict in the our model or machine learning, we just need to do the feature scaling part. We'll reduce these features from 0 to 1 or -1 to 1. -1 to 1. That is nothing but standardization and normalization. Okay. This is the formula, z-score formula and normalization formula. You can try on these examples. Right. Then we have to do the outlier treatment. We do by there are 5 ways of dealing with the outliers, detecting the outliers. But to handle, we are already having 3 types. This is the example of the third one. Remove the outlier, use quantile method, enter quartile range, then use the machine learning model. I already told about this. Box plot, we discussed something look like this. Yeah. And this will look like this. Yeah, it will look like this box plot. Histogram, everyone knows scatter plot is nothing but the scatter of the data in dot 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 dot, and we try to predict the model like this. This is the range in which the most of the data are lying. But what will happen, okay, some data which are outlier will be present outside this. So this is scatter plot. Just we talked interquartile range is nothing but the 25th to 75th percentile range, and we try to convert. If we find the data is out of 25 percentile, we will consider it as an outlier. Right. So there are a number of ways to handle invalid value. Unicode, encode Unicode properly, correct incorrect data types, then correct value that go beyond the range. For example, minus in the negative age value, or say those values which can't cross something. Let's say right now the maximum top speed of the car is 1000 km/h, let's say, but it can't reach 10,000, right? So that is a knowledge based thing which you can correct if you find any of the outliers in such scenarios. Then correct wrong structure. We talked, like for the pin code we talked, okay, we had a talk on this. Okay, if pin code is in the 6th digit, then it's fine. But if somebody wrote pin code in 10th digit or 12th of the digit, or they didn't mention, so what should be the correct scenario? We can do the handling if the values are not of the correct data type. Let's say if somebody put in the age, or in the age column only, they put like, instead of writing numerical 18, they do like EIGHT and the spelling of 18. Okay, 18. So what does this means? Yeah, this is correct, but the value is in the string format. So we have to deal with all these invalid values. And for this, there are a number of ways. Just we have to do the analysis first, then check the data type, what it says, how to check the data type of all the entire data frame. Just put a command df.info, df data frame.info. You will get the data type of all the columns present in the data frame, right? Not this, braces. Types of the data, there are 2 types data, qualitative and quantitative. Earlier was the sourcing of the data. This is the types of the data, how data is you can find. Either it can tell you a quality like good, bad, or like grade we talk, no, A plus, O, A negative, or something like that. So that is about some quality data, right? So but instead of this, quantitative means it will be some numerical data. For example, 1.2, 12, 36, or how many years are there, what is the current year, 2025, how many months are there, 12 months are there, how many hours are there, 24 hours. So what is current temperature, 33.6 degrees Celsius. So in this way, if the data is in decimal or some numerical format, then it is a quantitative data. A variable which quantify the population, numerical values. You can read this, right? I'm not going to teach. Nominal is nothing but, again, this good, bad, yes, no, male, female, which don't have any like superiority in them. But ordinal means A plus is greater than A, or B. A is greater than B plus, and O is greater than A also. So the point is, this is the ordinal which carries some type of precedency or like the priority list. In the discrete, just direct to the point values, continuous values, you can put like 32 to 40. In discrete, it's 8, 12, something like that. Or this can be 3.6 also. Any values with a decimal or some range part, that is the continuous. Types of data, you just go through it. Right. Then today topic we have to start from types of analysis. So let's start with the basics. Let's open our this part and we'll make it full screen. Right. Sorry, this one. See, types of analysis, what we have to do for the types of analysis. There are currently 3 types of analysis: univariate, bivariate, and the third one is multivariate. In the univariate, what happens now? Okay, if your data frame, or if you are dealing with only one column, then it is univariate. Univariate, what does this means? Uni means one, variate means variable or feature, you can say. Right, variable or feature or column. For better understanding, I am giving this name. So let's say age, you are dealing with only age. This is a univariate analysis, right? Or let's say you are dealing with gender. We will take an example where we are organizing an event. We had organized an event of, let's say, a popular singer, right? And so this is a cap, right? Don't think why I put row on his head. See, so but we found that there are thousands of people, 10,000 of people, and out of 10,000 we found that 6,500 were males and 3,500 were females. So this is if you are dealing with only one type of data, that is over here it's gender. If you are dealing with only gender, then it's fine. Then it will come under the category of univariate. Or you try to plot this data. Let's say in histogram you plot it like this. This is somewhere 7,000, 7k. This is somewhere between 6k. And dash dash dash. And over here you plotted like let's say this is 3k. You plotted over here like this. Right. So this is around 3k, and a little bit above that is for 3.5k. So these are females, these are males. If you want to put the bin, you can put 6.5, 3.5. It's fine. Sorry, not bin, the data part. Like if you want to get the value, this is not nothing other than annotation. Hence, if you want the value, numerical value, you use annotation. Right. So yeah, again the problem started. After this, the main conclusion we can say, it deals with a one variable. Okay, either it can be numerical, either it can be categorical. Right. This was the categorical data. Male and female are there. No, then we convert it into 0 or 1 or something. So this will come under categorical data. And if we are dealing with some age related thing, let's say we have age 18, 19, the most of the are were the college student in the function. No, most of the people who attended were college students. So let's say the data we have is 18, 19, 20. So definitely here we are going to use the static jo bhi hoti spelling, you try. See, I'm very bad at remembering the spelling, so you guys can learn it by yourself. So we are going to use statistics to get the, okay, what is the minimum value, what is the maximum value. I'll write minimum is 18, maximum is 20. What is the mean? Definitely 19. What is the median? What is the mode? What is the standard deviation? So you guys calculate this. For this data it's easy to find, but let's say we are going to find what is the 25th percentile, what is the 75th percentile, right? For the data, if we in the univariate, if you are getting to deal with the numerical values, or in any analysis, if you are going to deal with the numerical analysis, you have to go for the statistical. If you are going for the categorical data, definitely you are going to check for the distribution, how it is distributed. Like over here, no, we distributed the data in male and female. So if your data is in categorical, let's say CSC AIML students are more as compared to CSC AI robotics. So this is one of the fact at DSU. But the point is, okay, over here you by pictorially you have the data, right? So you can give like, okay, 99 point, no, not 99, let's say 80% of the data is of AIML student and 20% of the data is of AI robotics. So whenever you have a categorical data, you have to go for the distribution part, right? This is analysis type. See, there is one difference, that is the number of columns which you are using. If you are using more than one column, see, if you are using one column or one feature or one variable, that it will come under univariate. If you use two column, two features or two variable, it will come bivariate. If you are using more than two plus, then it will come multivariate. Rest of the things are exactly similar, right? It is a classification. It's just we are naming it, okay, it will come under this analysis, but the part what you do in the univariate will definitely be the same as bivariate. But in this case, you will be comparing two things together. In the multivariate, you will be comparing more than two things together, right? This is the basic point you should consider before doing the analysis. Or like, you should not distribute, okay, univariate is something else, bivariate is something else, and multivariate is something else. No, just the number of feature will define the name. If somebody asks you what you did, the univariate analysis or bivariate analysis, what you did, so definitely count the number of columns and answer it. It's easy, it's not a big issue, right? So after this, we'll go for the distribution. I'll show one thing of the distribution, how a feature can be like related to each other. For example, we'll talk about gender only. For our concert, let's say concert, anything, any like majorly AP Dillon or something, again I don't know his spelling, or Honey Singh or something, Diljit Dosanjh, let's say any example, your favorite singer, put his name over here and let's start, right? What you thought, what you find that okay, the gender distribution was like this, okay, out of 1,000 people, we'll talk about 1,000 people, 510 were male and 490 were female, right? I'll put this as a mark of 500. This is the number and this is the gender again. Over here you can type gender, and this is male, this is female. So right now the distribution of the data is not making a huge difference. Over here the data is distributed into 510 is to 490. If you divide or make the ratio of it, it will come nearly approx to 1:1, right? So this is not making a huge difference, or this is not giving us a more impactful thing. You can say that in the concert of Honey Singh, like my favorite singer is Honey Singh, we found that number of males were equal to number of females. So this is one insight, but this is not a big feature which you can think like, oh my god, because of this more males were there, so the cold drinks selling was more as compared to if the female were there. So if female were there more in the number, then popcorn sale were more. So right now it's equal, so you can't predict anything, okay, because of this happened, because of this that happened. But instead of this, if you find one more example simultaneously next to each other, we'll draw over here only, right? Let's say we find that number of male were 730 and number of female were minus this, no, 270. Again, it's not a good graph. You should plot meaningful one, 270. Again, this is number, this is gender, male, female. Yes, we find over here that right now the ratio is not in the 1:1. It's not in 1:1. It's instead it will be like it's 27 or like 25 3 1:3. That is 3:1. The ratio is nearly 3:1. Might be 2.9 something. but yeah, roughly it's 3:1. You better use calculator, divide 730 by 270, you'll get the answer, right? So it's 3.2. 27 into 3, 7, 30, 21, 2, 3, 2, 6. Oh no, it's 2.9 something or 2.8. You better use calculator, you will get the ratio, right? Let's say 2.8 for now. It's 2.8. 2.8 is to 1. So right now you can say the number of males are nearly 3 times as compared to the female, right? The males are 2.8 times. Now this is a one insight, a great insight which you can tell or you can find out is the number of male were more as compared to number of female. So what would like if you are having something, let's say wine shop or something over there, so sell of cold drinks or like anything, sell of drinks were more. Right now we are dealing with over here, I discussed about the one variable, right? When you combine it with the another value, okay, sell of drinks, that is the another variable, so it will come under bivariate, where we are comparing two of the features simultaneously, so it will give, yeah, because of this happened. So this was the one variate till here. Now we'll go for the slightly not deeply in bivariate. Let's say for the cell of drink, no, where more in case of when male were 2.8 times of the female. So let's say this is our graph for the first event when the this one only when the number of male were 510 and number of female were 490. So the cell of the drinks were in this scenario where let's say 300 and over here the, let's say this is drink, this is popcorn. Again I'll put the similar only to make it more clear. So let's say 310 for the popcorn, and for the drinks this is the column, right? Again this is the number, this is the 300 okay, nearly roughly both of them were sold equally, right? But over here when this case occurred where the male were 2.8 times of the female, we saw inside that in the data only we found that the number of drinks now sold were around 700, but over here in the popcorn it slightly decreased as compared to earlier because 490 is now decreased to 70. So 700 was that 310 will be decreased to around 150 or 160 something, right? Because definitely females are less and males were more. So you can say that because of this feature, because of this analysis, this feature, our sales were more, sales of the drink column were more, right? You can get this as one of the analysis. So this is how bivariate works, when two of the feature you compare simultaneously and get an insight, right? So yeah, after this we have another topic that is multivariate, and let me check for is there anything else I can help you in this. Okay, I'll introduce correlation now. That is nothing but the relationship between two attributes, right? I'll tell you how. Over here now we found that male and age and cold drinks and popcorn, age and snacks, we can say both will come under same. So we compared age and snacks, we found some insight. But right now how they are correlated, not age, sorry, this was the gender, right? Gender is snack, how they are correlated, now we will plot this. Or we can take another example also, that will be more easy. We'll take example of age and salary. Okay, let's say as you are a new person in this industry, in the tech industry, definitely your salary will be less as compared to the person who is at a higher post, right? Correct. So let's say कि this is the age axis, and okay, we'll plot this as age, we'll plot this as salary. You can do anything. It's not a big issue. Salary. See why I did in this left side, because I can put easily this data, no, let's say 18 to 30 and over 30 to 40. Let's say make it 20 to 30, 30 to 40, 40 to 50, 50 to 60 and 60 plus. Over here at the starting 0 by 0, like 0 age is 0 salary. But over here when the person was at the age 20, 30, like right now we'll put here $100, $500, $1,000, 1,500 and 2,000. Just an example, right? So the how the graph will be like, as your age, as the person age increases, let's say we have 500 people data, 5,000, let's say 5,000 people data. We can see that most of the things will be like, as the age increases, their salary is increasing, right? So you can see a trend most of the people will be the same trend, like the dean of the university or like a professor. So as their age increases, their salary increases. This is a normal trend, right? So you can say this is in an increasing manner. Means as age increases, salary increases. You can find some outlier also at the early age. A person can from IIT or from a good institute, or he worked so hard, so he got a like salary of $1,500 at the age of 25 or 27. But whereas a case can be there, such as watchman or something, where his salary is $100 at the age of 40, right? So this can be the exceptional values present, which can, these are only outliers. This is only outliers. So sometimes you don't have to drop your outliers, or sometimes you need to drop. So it depends upon the use case which you are going to use. So over here you can see as the age increases, the salary is increases. Means age is directly proportional to salary. That means age is positively correlated with the salary. Means if something is increasing and salary, another feature is also increasing, which means yeah, there is a positive correlation. And the magnitude, like how much times, see, if age is increasing salary, it's fine. If age, by increasing the age, salary is increasing two times of the earlier one, like twice. So it is two times correlation, right? Means earlier it was for the 20 to 30 years, it was $100. For 30 to 40 years, it was nearly $500. But what happened now? At the 30 to 40 year, now it is $1,000 over here. Means like over here something 30 to 40. So the correlation from here, 500 to 1,000 was twice of it, right? So now the trend will be morely like this, mostly like this. And definitely, see, at the age of 60, somebody is earning 2,000, and salary is here for the 40 and 50 person is earning more. For the age 60, he might be earning more as compared to $2,000. So this defines the numeric value, how much time, like we can say slope. This is nothing but slope. If the value of the slope will define you, okay, how much the correlation is between. See, 2 is not possible, because slope 2 is not possible. But apart from that, yes, you can check, like I'm giving an example. So that will be slope will be 0.5 or something that. So it is increasing twice. So yeah, let's go for the next thing, that is nothing but your multivariate analysis. Okay, so yeah, just a second. No. Okay, I should close my mailboxes over here. Okay. I'm just making some little bit of space so you can relax by then. So let's start with the multivariate analysis. Multivariate is nothing but when you're dealing with the multiple values, multiple features. Let's say you can have more than 2 plus features where you are considering age, salary was there, no? And one more feature, let's say marriage or education. So see, as your age increase, there is a high probability that person education also increases, level of education, right? And definitely salary also increases and chances of marriage also increases. But you can put inverse of that, ki, like negative correlation means ki if something is increasing, then something is another of the values is decreasing. That will be negative correlated. Let's say when your age is increasing, then your health activity or like your uh, fitness is decreasing. Initially, as your age increase till the age of 30, your fitness also increase. But as you increase your 30 age from 30 to 60 or something, your level of fitness will be decreasing, right? So this is the main part where it is a mix of positive and negative correlation. For the first half, it is positively correlated. For the next half, it is negatively correlated, right? Okay. In this, we have one more topic that is called as heat map. Okay, I'll tell you. See, so when you're having a data set of let's say 5,000 people in which the columns are age, salary, marriage, level of education, fitness. See, every five of the features matters. Actually, this matters. But depending upon your question, if your question is ki, okay, these are my employees, tell me how much physically fit they are. Or let's say how much stress level they have. Right? Stress level. So in the stress level, salary will play a vital role. Level of education doesn't play. Age, yes, it plays. Marriage, yes, it plays because after marriage, he might have or she might have babies at home, so he have to take care. Like financial budget also increases or family pressure also increases. So this is a key important feature. Salary is also a key important feature. The number of people are increasing in the family. Definitely, salary need to be increased. Then let's say age. If he is getting old and old, so definitely stress will increase and if he has less of the salary. So the main point over here is ki if your company is asking a question ki do the analysis of our employees data set in which you have to find ki what is the stress level, our average stress level, or are they in the stress or something like that. Okay, so okay, let's make the sense, but our level of education doesn't make a vital role, not a vital as compared to age, salary, marriage and all, but yes, it plays role but not at highly correlation. So this is known as multiple uh, kya multivariate analysis where you have to go through each and every. See, so before that in the bivariate, what we did, we plotted age one side, we plotted salary another side, and we draw some line or something negatively correlated or positively correlated. See, this is positively correlated. This is as the age is decreasing, the salary is also decreasing. Again, it is positively correlated. So if you want to draw the negatively correlated map, if your age is increasing, your salary should decrease, right? So if your data is like this, if your graph is, see, this is from here to here, over this way, and your data is like this way. In like salary is also increasing in this way. Or you can do like this also. Okay, let's say this is the age 18. As the age increases, your salary is getting decreased, no? So it is either at this point only, or he is getting 19, his salary is still less, still less, still less. So either this, that is static, or either in this way. So if it is in this way from here, which means that yeah, age is increasing, but salary is, see, better we should not put this as zero, means it will be, if it is in negative, means he is paying salary at a company, okay, give me the job, I'll pay you. Means he will pay to the company. So it definitely it should not be in the negative, but yes, means that's why I was putting age over here. age, salary. Okay, see, definitely if you put over here and salary over here, definitely age is 18. If the age is decreasing, the salary is increasing, right? Let's say some billionaire child, so at age of 17 he might have a salary of billions, but whereas a person at age of 40, he's having less salary. So you can, if you are trying to plot a graph, definitely it's going to be negatively correlated. But yes, definitely it decides where you are plotting, what is the direction. Right. So let's go to the next part. That is heat map part. Sorry. So in this we are going to talk about how one feature is correlated to the another, rest of the other features. Means age, marriage, education level, salary. One more where there, no? Age, salary level, fitness. Okay. So over here, what we'll do, okay, sorry, a call was coming, so I got distracted. Marriage, education, salary, and fitness. Means we'll plot this like this way. Right. Means age. Oh my god, I made a mistake. One more over here. I should remove this one. This one. Okay, age is definitely directly dependent upon age. Yes, the correlation will be positive one. Marriage is correlated with marriage. Yes. Education is correlated with marriage. Dependent upon education. Yes. Salary is salary. Fitness is fitness. So highly correlated. Let's say education is not dependent upon marriage because he was having his own education before marriage. So it is negatively or not related. So if it is not related, we'll put a value 0. If it is not related. If it is somewhat related to the salary, okay, if your education increases, your salary increases, we'll put like 0.6, which means, yeah, there is some relation, right? And let's say your age and fitness decreases, so 0.5. As the age increases, your fitness decreases. And again, see, there is a property. Okay, this is your salary, right? This column, salary column with education column. So here also salary column with the education column, like this way, will be having the same values. Again, fitness and age and fitness. So here also 0.5 of a negative. So you'll get a matrix over here. This upper right side of the triangular matrix, no, will be equal to the lower triangular matrix. Right. Give me the name. Okay, in the comment you can put what is the name of the matrix when the half of the left triangle is equal to the values of the matrix of the upper right triangle. Right. So what we call to this matrix, something symmetric or something we say, no, symmetric, skew symmetric, or what, just put it in the comment if you are there. Else learn, otherwise skip the video, no issues. Okay, see, marriage is correlated with marriage, but age is correlated with marriage. Yes, let's say 0.4. So over here also 0.4. Education is correlated with age. Yes, age increases, mainly people will increase their education, so we can give a rating of 0.7. And again, as age increases, salary increases. Yes, so 0.9. We'll put again marriage. As marriage, is a person married? Yes and no. Is it dependent upon education? Let's say yes, slightly. So education and with the marriage is, see over here, education marriage, it's not full. Education marriage is 0, no. Over here it's, if I'm putting 0, so I will, the value in the graph generated by the computer will also have the same value. So if it is 0, so it will be also 0. 0.6, then yeah. So salary with marriage, did I put something salary with marriage? No. Let's say 0.2. I'll put 0.2. If again, fitness with marriage, might be a, but still let's say 0.15. And here education with fitness, the people who are more oriented to education, they are less oriented to their fitness, so you can put 0.20. And salary with fitness, again same, you can put 3.5. Now we have a upper right side of the matrix, right? The upper right triangular matrix. The same value will be of the left. Education with the marriage. What is the education with the marriage? Education with the marriage 0. Now education with the age. So age with the education, that is 0.7. So I'll put 0.7. Okay, let's change the color. That will make little bit good now. 0.4. So marriage, see, next to next will be the same, no? Marriage with age and age with marriage. So 0 here to 0 here, 0.6 to 0.6, 0.35, 0.35. Right, the condition is the next the column should be in the same manner as the rows are there as in the columns, right? So over here it will be education with age. So what is education with age? Education with age is 0.7. It will be 0.7. What is salary with age? Salary with age is 0.9. What is fitness with age? That is minus 0.5. Then what is salary with marriage? Salary with marriage 0.2 and salary with marriage 0.2. See why I'm telling you this, why I'm taking time in this plotting the matrix, because heat map is a main thing which n number of time you will be plotting. So you must be knowing okay how it has done or it is getting done by the Matplotlib function or Seaborn function, right? Mostly we use Seaborn, that is .corr function in the Seaborn library to get the correlation, right? So let's I was telling you why it is necessary. Fitness and marriage. Where is fitness and marriage? Go in the marriage, go for the fitness 0.15, put 0.15. Fitness and education, so go in fitness and check for the education, that is 0.20, 0.20. Right, so this is a overview of your heat map, right? So many of the heat map you can put the colors also. So instead of getting your annotations over here, that is annote is equal to true, instead of this, if you put annote is equal to false, is nothing but this values will not be shown. So instead of this, the color will be shown. The which are most highly related or negatively highly related, that is 1 and -1. This will be values will be in the darkest color of your color palette. What is color palette? Color palette is nothing but the range of different types of colors. See, like you have seen, no gradient. I think so. It has one function, but earlier in the OneNote it was there some more. I should check. See, like over here, no, there is a spectrum. You can see that is negative, blue, green. As I'm slightly increasing, there is a change in this color, right? This box color. See, this is the your what we say color gradient, or you can say that the color mapping. I forgot the name. So as you can see, the more highly dense color will be, that is the 1 by 1 is means highly correlation means the darkest color what you can possibly imagine. So it depends if you're talking about black and white, so definitely it will be you can find black and white, no, some gray and black, or if it is in dark blue and light blue, so the lightest blue will be given to the least correlated values, let's say 0.2, 0.3. For the darkest will be positively or negatively highly correlated, that is -1 and 1, right? So we'll see. 0 will be the least color, like light color, the lightest color, right? So this is nothing but your scale which we use to get, okay, when I'll show you at that time we'll get. So there are more two types of graphs which you can use to get the correlation, that is kernel density plot. Okay, I'll use this only, kernel density estimation plot, and one more plot is there, that is histogram. Everyone knows this histogram plots. So this you can use extra apart from correlation heat map to plot your data, right? And KDE plot, this is also known as KDE plot, kernel density estimation is nothing but KDE plot. It represents the data as a continuous probability density curve in one or more dimensions, right? So whenever we like in the code, I have plotted KDE plot also. If we found that, definitely I'll tell you what's the main function of that KDE plot, right? So let's go to the PDF. We'll read the PDF now. Univariate analysis is the simplest form of analyzing data. Uni means one. So in the other words, your data has only one variable, right? Then bivariate data which has two variable. You often want to measure the relationship that exists between these two categorical variables. Also, it can be performed on the numerical also. So it is not limited to categorical or a combination of numerical and categorical values. So yeah, definitely we can do. Multivariate means more than one, has more than two variables. You often want to measure the relationship that exists between these features, right? So numerical analysis, we perform various analysis over numerical data. Similarly, while analyzing multiple features, we might be interested in knowing their correlation with each other. So that's why we plot heat map. For example, dealing with a single numerical variable might be interesting in the knowing the statistical information such as mean, median, 25th percentile, 75th percentile, and minimax. I told you. See, derived matrix is nothing but we are going to get the sum of the insightful information from the data by analyzing the data. Means we are going to create something extra thing from the existing variable to get insightful. For example, see over here it's written no derived matrix create a new variable. Matlab create something new from the existing variable what we have to get an insightful information. For the feature binning, let's say before going to feature binning, I should tell you. Okay, we'll go for the PPT at last. Right now we should focus on. Okay, derived matrices. So it's nothing but when we are going to create a new variable from existing some variables. Let's say age, height is already given, and we want key. Okay, we will combine both of them, or we will. Okay, I'll give you a basic example, not the high level example. So the basic example you can say. What I was teaching? Derived matrix. Okay. Let's say we have a degree. See, I forgot a lot of things very quickly, so don't judge me on that. See, let's say we have a degree column. Over that we have BSc, BTech, B Pharma, BSc, BTech, B Pharma, BA, LLB, or BA. Right, some bachelor's course or anything. Let's say we have right now 2, 4, 5 of the degree in the bachelor's level, and in the same continuation in the list of the same we are having BA, then PhD also, MTech also, MBA also, MCom also. Yeah, MCom, so BCom, and MA is there, MA, PhD, dual PhD. So I'll write 2 PhD. So let's say we have this data and we want to get some of the insightful data. Let's say you are going to train your model on the behalf of this data. So you don't have to encode BSc as 1. If you're going for this, then definitely it's going to be a huge blunder. You should not do like this. There is one more way, like the frequency encoding, in which how many times BSc has appeared. You will change the value of that after taking the mean. Like we'll get the mean of this data, we'll compare with the BSc and mean, we'll replace it to the feature, right? So this is a feature engineering, we'll let you know why it's getting changed. Okay, let's say BSc is there, then B Pharma. Okay, if you encode it like 2, 3, BTech is 4, BLLB is 5, BCom, MCom is 6, 7, 8, 9, 10, 11, 12, 13. See, right now we are having around 13 or 12 features, but as you increase your number of features or like number of values in the degree or parameters in the degree, definitely you have to encode it n number of times. Again, your computer will be biased towards this. Okay, this is the 0, 1, 2, 3, 4, 5. But similarly, you are giving 10 also, 12 also, or 22 also. And it might get also confused with the rest of the data, which are between 0 and 1. Then again, computer will be biased towards 0 to 20, 200 to, 24 or 12 or something. This number of values. right? So not to make this happen, what we'll do, we'll categorize the data. Okay, if it is starting from the bachelor's, no, that is B, we'll cover that part in a one category. We'll call it as together as 0 or 1, or we call it as bachelor's, right? We encode it as 1 now. And for the master's program, we'll call it encode it as 2. See, right now, earlier we have 13 features, right now we have 2 features, and this will become your third feature if you encode PhD and dual PhD. Third feature. Now computer will be less biased, or zero negatively not biased, actually it will be not biased, right? So this is the point why we are going to use the derived matrix. Means what we did, we earlier had a list of the degrees, like some 13, 14, 15 degrees. And what we did, we just categorized the data of this degree into particular values. 0, like that is bachelor, 1 that is master's, and 2 which are doctorate. We say no doctorate, this master's and this bachelor's, right? So this will help you, definitely this is gonna help you at some time. Okay, while you're training your model, no, at that time you can convert like this. So this is why I use derived matrices. That is feature binning, feature encoding. From domain knowledge, I'll calculate from the data. Feature binning is nothing but to convert or transform your numeric values into variable which are more likely to be, I'll show you over here. Okay, this is why I hate. Okay, see, you can say like feature binning doesn't do a great part. You can write, it does a great part, but you can write like this. Okay, feature binning just converts, or you can say transform is a better word. It transform your continuous numerical value, like continuous numeric values or categorical values, or you can say transform continuous. I'll give you a definition on in this only, it will be there now. Why we should do this much? Convert or transform, transform continuous numeric variable to categorical variable. It can also be used to identify missing values or outliers. Yeah, see, this was what I was talking about, equal frequency with binning, equal width binning. Okay, so right now frequency feature binning converts or transform continuous numeric variable to categorical variable. Means transform continuous numeric variable to categorical variable. For example, 1, 2, 3, we have some numerical values, right? Or over 4, 5, 6, 7, or some numerical variable. So how you can convert into the categorical value? Converts transform continuous or numerical variable to categorical value. It can also be used to identify missing values or outliers. Okay, first we'll go with the first part, how we can convert. See, equal width binning. Over here, what will happen now? Equal width, or BIDTHOB, equal width binning means the basic binning. Let's say we have age data like 18, 19, 20, 22, 26, then 27, 28, then again 18, then 19, then 30, and in between we can put 37, 12, 16, 35, something like that. If we have the list of the data like this, 46, 42, what we can do, we can create binning of the equal width. Okay, means for every 5 data, let's say 18 to 20 we'll have some data, right, X data. Then 20 to 22, we have some Y data. This is equal width binning. 24, sorry. Then 24 to 26, Z1. 26 to, or like you can change, definitely you can do, instead of 18 to 20, you can do for 18 to 22 to reduce the number. I'm giving you an example. So over here we are having 18, 19 and 20, 3 of the data. It should be, okay, I made a mistake again. Okay, we'll not consider the last part. We'll exclude that part. Means 18 and 19 we have over here. In this, 20 and 21 we don't have 22, otherwise I have to write it again. That's what I'm saying. So the point is ki this is the equal width winning, where we are giving ki okay, this range to this range will be here, and the difference between both of the number, and we are doing it n times for the n ranges, right? So this is equal width winning. So what is equally frequency binning? Let's say we have uh, the bins will be created. Uh, the bins will be created depending upon the number of frequency. Let's say 18. How much 18 we have? To right. So equally frequency. Let's say 18 to something. Let's say the minimum number is 2. So 18 to 18 or like 18 to 19 will be maximum value is maximum value is 2. So now the frequency base means ki the frequency will be taking in the consider. Right now my this pen is not supporting me. Whenever I'm going to write, it's giving me some error. Right. It's C right now. Again it changed to the mouse. This eraser. So n number of time I have to change. See, equally frequency binning. Remove this example for right now. Let's say we have a data of this only, and we want to convert this data into equally frequency binning. So the number of the data over X, Y, and Z will be same. That is equally frequency binning. Means the numbers. Frequency means the number of the data in this parameter. So the parameter is not necessary. It should be 18 and 20. It can be 18 to 30 also. If the total number is, we set ki okay, the equal number should be like equal number of the data parameters present in a particular column should be 5. So 18 to 30, if there are only 5 values, so it will be 5. Or 18 to 20, if 5 are there, then this will be the limit. Another limit can be from 21 to 30. Okay, let's say 5. Then 32, in the 32 age, we got already 5. And in the 32, we got 33, we got 5. So this is called equally frequency, means the number of elements present in the particular range should be equal. And this is how you can replace your data, right? Means what we did the discrete value. These are discrete values, right? We converted discrete values into the categorical values. In some categories we divided. That is nothing but feature binning. Equal width binning you got, equally frequency binning you got. It transformed continuous numerical variable into categorical without taking independent. Equal width means equal width separate the continuous variable to several categories have same range of width. Equal frequency separate the continuous variable into several categories having approximately same number of values. Like I gave, no, this is the same number of values. This is the same number of values. X values are there. In this another parameter, same X number of values are there. That is equally frequency. And what is equal width? Means if you are having some 18 to 20, let's say, then again it should be 20 to 22. That is the equal width we are having over here, 2 or 3. Right, that is feature binning. Okay, let's go for the feature encoding. Feature encoding helps us to transform categorical data into numeric data. It is just opposite. Over there it was numerical to categorical, it's now categorical to numerical. So what we did in the categorical to numerical one, just a second. Okay, yeah. This was the numerical to categorical, right? Numerical to categorical we divided this one. Now we have to do the inverse, categorical to numerical. So what we can do, we have to do the inverse, that is categorical to numerical. How we can perform, I already gave an example, I think so, in one of my video. For the categorical or categorical part, you can do what you can do. Let's say you are having a range. How you can see, same example we'll take. Let's say we have a data from 18 to 20. Either you get the mean of this value, what is the mean age between both of them, that is 19. Let's say for 19, replace the column with the 19. That is feature engineering, encoding, feature encoding. Or let's say we have done a lot of feature encoding. I'll give you an example now. This is an example. This is an example. This is one of the example of feature encoding. Right, where we are having n number of categorical data and we converted into the numerical data. We converted it into 1, 2, 3. Right. This is nothing but here feature encoding. So I have already covered. That is the feature encoding. Label encoding, I'll tell you. I'll tell you. Okay, what is feature encoding? Feature encoding. let's say we have a patient, we have a list of patient or the data set of patient in which we are going to ask ki how many number of hours they sleep, right? Number of hours they sleep. So some of them are sleeping less than 4 hours, some of them are sleeping between 4 to 6 hours, some of them are sleeping between 6 to 4 to 6, 6 to 8, and some of 8 to 10, and another 10 to 12, right? So we are having n number of categories, that is less than 4, 4 to 6, 6 to 8, 8 to 10, and 10 to 12. And the number of patients, right? Not right now, number of patient is not required. So we can't tell, let's say patient 1 is sleeping less than this is the patient 2, patient 3, patient 6, because patient 4 is sleeping less than 4, and let's say patient 5 is sleeping less than 6, and say it's getting changed again. This patient 12 is sleeping less than between 10 and 12 hours. So this is the categorical data. How I can convert this categorical data into the numerical data? Now over here we can see that there is a precedence. Okay, there is a order. This is the less, this is increasing, this is increasing, this is more increasing than the previous one, and this is more increasing. There is a precedence. Precedence means nothing but some level of it is getting higher and higher, right? For this, I'll prefer go for the ordinal encoding. Ordinal encoding. Or label encoding is also better. Ordinal means ki it will give your data some priority. Okay, these data are some priority data. But label encoding you can do by your own. You don't need to say less than 4 should be 1. You can change, that is giving a label to your data, right? We will read the definition. So how we do the encoding, you can see over here. See, less than 4 I told okay 1, 4 to 6 we told okay 2, 6 to 8 we give as 3, and 8 to 10 let's say 4 and 5. And if there are greater than 12 hours, we will call it at the category 6th. So now we converted a categorical data into some numerical data, right? For some precedence wise. This is nothing but your feature encoding. Label encoding is the technique to transform categorical values into numerical values by assigning a numerical value to each of the categories. In this only label encoding, it comes that ordinal encoding that will give you an order. That's it. One-hot encoding is nothing but creating of the dummies. This technique is used when independent variables are nominal. It creates k different columns, each for a category, and replace one column with 1, and rest of the column is 0. Here 0 represents the absence and 1 represents the present of that category. Okay, better I'll give you an example. I'll show you an image of one-hot encoding. See, we create dummies over there. See if a category is already there present. Let's say for the red one, no? This one will listen. What was that? Okay, this is also good. Okay, Safari problem. Okay, till by that Safari is loading, no? Yeah, it worked. Why it is lagging? Might be some website issue. Okay, see, we have this. Okay, now it's clear. Yeah, video is going on. See, the point is ki over here we got some dummies. Let's say we are having a color that is 4 different colors: red, blue, green, blue again. So what one-hot encoding does, it will create a color in option of the column of the red color, one option for the blue color, like column for the blue color, one column for the green color, and blue we already have, so it will not change anything. So what we'll do, whenever there is a red present, we'll put 1. Wherever the blue is present, we'll put 1, else 0. If green is present, put 1, else 0. For example, if we do on the left side only, if you see red is there, and we created 3 columns, red, blue and green, the right side, we can see that 1 is there, 0 is there, 0 is there. What does it mean? Ki the color value it is having is 1 in red, means only red it is having, so it is not having blue and green. Over here in the second row, we can say the color is blue. So in the red it's 0, in the blue it's 1, in green it's 0. Again green 0 0 1, blue 0 1 0. Right. So this is your one hot encoding. Again, yeah, this is your one hot encoding. So finally, we are at our last slide, that is use cases. So definitely I'll create a, I think so, different video on use cases. Or let's finish this. I don't know how much time it's already done for the video, but on an approximate 40-45 minutes is left, like already done. So we'll go for, I'll show you the some basics code, how which I have already kept open. See, this is the basic one, how EDA is done. Why, what, data cleaning, data collection, cleaning, visualization, feature engineering, statistical analysis, handling outlier and missing values, correlation analysis, distribution analysis, and data transformation. Key libraries for the exploratory data analysis are Pandas, NumPy, Matplotlib, Seaborn. Seaborn is for advanced visualization, right? For correlation or something that. See, in data collections and loading, we have read CSV if your data file is in CSV file, read Excel if your file is .xlsx form, read JSON, again data is that your data frame or data set is in JSON form, or if you are using .sql data set, you can use read SQL, right? For the initial inspection of the data, we have head, tail, sample, info, describe, shape, column, index. We have already described this into the pandas. If you want to check, you can go. Else I'll give you a small intro of this. See, df means, what this syntax means, go for the data frame. What is data frame? Over here we are copying the data values of the CSV file. Let's say we have a CSV file, read CSV we used. We copied all the data of this data.csv into a frame, into a variable known as data frame using the pandas and the function read_csv. Right, now we have the data. If you want the first 5 rows, you have to call data.head. If you want the last of the 5 rows of the data frame, call data.tail. df.sample will give you the any random, it will pick any random and it will give you that sample. df.info, definitely I told you, it will give you the data types and how many null values are present. Then df describe means it will give you a numerical analysis, statistical analysis actually. It will give you a statistical analysis of the data of the numerical column. Over here I didn't mention, no, of numerical column only. Numerical column only. df.save will give you rows and columns, definitely. Columns will give you the name of the columns. Index will give you the how many rows are there. Then data cleaning, handling missing values. See, these are the same topics which we have covered in the lecture part. Handling missing values, if there are null values, how will check is there any null present or not. See, many of you will say, sir, do it simultaneously. Okay, here is the code. Okay, I'll do one more thing. I'll remove this part. Control C, Control D, Control V. I think so. This is okay. Fine. Yeah, it is half only. Let it connect. I'll do in the. I'll complete the this what we say. This part, use cases in this video only. I want the drive part. Yeah, I got the drive part. My drive EDA. Okay, content.html modeling.csv. Yeah, we have. Okay, fine. Let's run this. I'll close this. We don't need now. I'll do one part. I'll call it like this way. We'll do one thing simultaneously next to the code which I have created over here, so that it will give you a proper insight, right? sorry. See, I am new to this Mac, so definitely it's gonna take time to learn all this basic thing. Right, I'm not connecting this notebook because this is just notes. So how key libraries import pandas and definitely for the data manipulation. You can read the comments I kept for you only. See, over here we used read CSV. That is if our data format is in CSV file. See churn modeling.csv. Okay, I'll show you if it's okay. I'll download it. Okay, first let's visit how our CSV file looks like. I should remove from low battery. Yeah. See, this is our churn modeling. A churn means ki the people, how a customer is loyal to a company or something. You can say like, see, I'm new. Sorry, again, sorry. Okay. See, this is how our data is looking like in the main file, right? I didn't use VS Code or something. I just opened it .csv file. No Google Colab, nothing. These are the columns. Exited. Exited means did they stayed or they exited. 1 means yes, they exited the company. 0 means no, they didn't exit. See, customer ID is there, surname is there, credit score, geography, where they live, gender, male, female, age, again we have numerical data, tenure, numerical data. This is your float again, number of products. Yes, rest of them you can read. See, we'll find some null values if we are able to. Null values nothing means there is nothing present, like this, like this, like this, like this, like this, like this. Right. See, I'm doing at the downloaded file, so definitely these values are not gonna change over the main uploaded one. Let's say these are the null values, which these are the values not present in the data set. Right. So how you can deal with that? These are the null values. These are the rows. Yeah. Let's continue. Otherwise. Okay. Okay. See, I just copied the file of the path. Those who are having problem, just go over here, upload it. Right now I'll upload the same thing. Churn modeling with some deleted values. Warning, your files are saved somewhere else, the random will be deleted. Let's see if that file. Okay, I didn't saved, I think so. Okay, it's fine, no issues. I'm teaching you how you can access this data, right? How you can use pd.read CSV. See, we have a file. What I did, I just click on this upload, I select the file. Now over here, I'll copy the path. In the cell, I'll write like this, pd.read_csv. Now I'll share the location of the file where my data is present. So model, right? This is the data, but definitely it is a string value. You need it into the double quotes. Just put double quotes. Then this is also okay. If you run like this, it will run. But better you put an R, means if somewhere a special symbol might be there, let's say at or something, so it will not create a big problem. That's why put R. R means just read this. Don't takes, for example, /n means next line. But if you put R over here, it will not go to the next slide or something. It will just read as /n. Okay. So that's why better to use R. Put shift enter. Close this. Right. Then to get your basics of your data, how your data frame look like, you could do df. We'll get the basics. Yeah, right. Okay. We'll perform the rest of the part. df.head is nothing but we'll get the first 5 data. df.head, sorry. See, what are the first 5 data? Hargave, Hill, Onio, Boni, Mitchell. Hargave, Hill, Onio, Boni, Mitchell. And what is the last 5? Walter, Sabatini, Liu, Johnstone, or something. We'll put df.tail. I'll put like this. We'll get the last 5 values. Yeah. Now, if you want any random values, okay, bhaiya, I want some random values. Definitely, you can go for the sample part. SAMPLE. It will give you the sample. See over here, I didn't mention anything. That's why it's giving me 1. If you pass 3, you will get 3 sample, random sample. And if I do 4 now, 5 now, see there is no number starting with 4. If I run it again, it will pick some other 5. do it again. At least, yeah, 4452781. Now you got some in hundreds only, right? So you will get the random 5 data. After this, if you want to get the statistical info, okay, how many, not statistical, okay, for the statistical you can go for df.describe. See, you won't get customer ID because it's a categorical, you won't get surname because it's a categorical data, right? It's not a numerical data. So whenever you use describe, describe function, then at that time you'll get the values of the numerical column only. See, row number, customer ID, credit score. See, the surname is dropped. No, not dropped, is skipped. So this is the way you can say, or put dot t, capital T. That means transpose. So now the columns will become left side and the count mean standard deviation. This is the better way to visualize. I use this way. You can prefer any of them. Okay. Now after this describe, we have shape. Shape is nothing but how many rows and columns are there. df.shape. Not this one because it's not a function. df.shape means 10,000 rows and 14 columns we have. But if you want to check how many null values are there, how many exact values are there, df.info is a one parameter, like function you can type df.info. See over here, there is no null values right now. That means, okay. And how many categorical values? See, you'll get a data type as object for the categorical. First one is the surname, second one is the geography, third one is your gender. Yeah, fine. So 3 categorical values we have, right? Then, okay, we'll go for columns. If you want the column name, again, df.columns. Sorry, not this one. df.columns. You'll get the list of the columns, irrespective of their data type. Then, if you want the index, row indexes, how many indexes are there? It's no, because when you print df.info, no, you'll get the range index, right? So that is starting from 0 to 999 and 19. Then we are going to do the data cleaning. So we'll find the how many null values are there. So we'll put is null. Okay. So if you put df.isNull, it will say true or false. Okay, this value is false, means yeah, it's not a null. If somewhere it's true, no, means that particular place is null value. And if you want to find how many there are null values, put sum, total sum it will go. I've already taught this in the pandas class, how this sum works. So I'll just skip the main part. I'll just explain in a small bit. Then again we have, see right now we saw there is no null values, zeros. So if you put null, if you want to drop NA, and you are going to pass that key, okay, in place means, okay, replace that, in place is equal to true, sorry, TRUE. Again, there is nothing, no, because we got nothing because we didn't print it something, but still we have zeros, null values, so nothing will remove any like no missing value will be removed. If you put df.fillNA, see, I'm telling you what will this do. FillNA will give, okay, it will replace all the values, FillNA, with what the value you are giving. Pass the value. For example, FillNA, and if you pass 5, so wherever there is a null value, put in place, okay, it will change the main data frame. That's why in place is equal to true. For it, FillNA 5 is there, which means ki all the null values will be changed to the value of 5, right? Then we have handling duplicate values. That means ki if, let's say, we'll check how many duplicate values are there first. So this is the code. Why should I type 3 times, 4 times? I'll just not text, I'll put a code. See, we found 0 duplicated values, right? If there are duplicated values, let's say 1, 2, 3, then we can use this command, that is drop duplicates. In place true, yeah, means yeah, remove that part. Again, syntax error because this is not used. Okay, better. Now after this we have correcting data types. Don't have data. Do we have tenure? Okay, what's the tenure? It's an age, right? Okay. See, if we have date time column, if you open, no, I have said a lot of 3 or 4 CSV files and around 5 or 6 or 8 of the IPYNV files. Go check them out. You have all the categorical, and I'll show you right now. I'll show you after this. I'll show you all this visualization part, everything has been done in that IPynb file, right? If you want to plot histogram, how you can do, just this is the SNS is nothing but Seaborn. You have to call Seaborn to plot, or you can use Matplotlib as well. SNS plot KDE. See, this is the KDE. What is the KDE? Kernel density estimation plot. Here I showed you KDE, kernel density estimation plot. That is KDE plot. So this is how you can say KDE is equal to true. It will give you the KDE. And if you want to get the photo, plt dot show. Okay, over here column you have to change which column you want. Let's say we want customer ID, not customer ID. Let's say geography. Yeah, this is the density plot. Okay, so okay, just give me a minute. So this is the point. Just a second now. Okay, so let's go for the after this histogram we will plot the box plot of the geography data. Okay, is there any outlier, and we'll change some numerical data. Let's say age is there, no, we'll change the column name to the age. We'll change to the age, and I think so capital A is there. So see, actually phone was coming from my mother, that's why I see there are an n number of outliers, as these are the 0 are there, no. This states that the outliers are present in the data, right? Then you can change to geography also. No, nothing is there, right? Because it's a categorical data. And again, let's use credit score. See, try, this is only EDA. Change with a number of plots. See, this is also having outliers, right? Okay, now if you want to count the plot of categorical values, put the categorical column. We have categorical column as geography, put x is equal to geography. You got count plot. Over here we have around 5,000 nearly France people, Spain 25 Germany also, right? Then if you want to do bivariate analysis, like comparing two feature at a time, over here we just compared one feature. So over here the features are nothing but a column. I'll compare age versus this geography. Then we will geography. Okay, this is doesn't came good. We'll change the exited. Okay, this is not a good one, but yeah. See, scatter plot, it's saying that exited 0 or 1 mein value hai, but if we change this to geography, zero, 1, let's change this to the age again. X-axis is geography France. We have ages of distribution like this. Okay, 90, there is a person of the age above 90 in the Spain also in our data set, right? This is scatter plot, that is dot. If you want to check for the we say heat map, if you want to display the heat map, means you want to plot the dependency of one feature to the another feature, that is the correlation you can do, right? But the point is key, you have to, like over here if I do like this, no, that df.curr, I got Hargrave could not convert string to float. Definitely, because there are n number of categorical data we have, and heat map df.curr and not true, cmap column, what's the error? Could not convert string to float, Hargrave value error. Somewhere might be the some in the numerical data also somewhere might be some strings, or that because of this only it's giving me cannot convert. Okay, we'll go for the next plot, that is pair plot. Okay, it's gonna take time. We'll do the multivariate now. We'll just group more than 2 columns, like category column. What is our category column? It's geography, and target is our exited, right? And again, until unless this is plotted. See why this is taking time, because it is giving you the multiple relationship between what are the where is info? Between n number of rows. How many rows are there? 13 rows. How many data are there? 10,000 of the data are there, right? See, for the each and every you are getting. If I zoom it now, see roll number to the row number, sorry, then customer ID to the customer ID. So it is giving you the scatter plot of all the relations what we have in our info file, that is pair plot. If you do like this, df.group by, like get both of them and give me the mean. For example, France, the mean people who exited was 0.16, 0.32 people exited from Germany, 0.16 people. This is the mean out of total how many they have exited from the Spain, right? Or if you want the what is the average age of the France, Germany, Spain people, you can change the exited to the age. You will get the average age of the France guy is 38.5, 39.7 and 38.8, right? So, or you can do also this, you can try exit, like those people who are exited, what is their mean age value. So for those who exited, that is 1, that is the mean age is 44. Those who didn't exited, their mean age is 37. Means those people who are above 40 age are more likely to churn, you can see. So this is one of your analysis. If you want to print the pivot table also, you can print it. Sales, value, sales, region, product. Do we have sales region? No, we don't have. Okay. We'll go for the another, that is statistical analysis. See why I'm making this much as fast, because we have already created a number of IPyNV files which are already present for your analysis. I'll share the link of each and every in my description below, in the YouTube video description, whatever we say. Okay. Okay, this is statistical. Let's say for the age is there and you want the mean of the age of all the person of the data. You can put df age.mean. If you want to median, you can just change this to median. Again, we have covered this into the pandas. Convert this to the mode. Mode is mainly used for categorical data, but okay. The median was 37. Whenever you're training your machine learning model, you can't say that better to choose mean or better to choose median. Each and every time you have to train your model with try training your model with the mean first. If it is fine on that, again come back, change it to the median, and again train your model, then compare the result. Does it making any difference? Then only you can say okay, it is good or it is bad, right? And if you want to check the skewness, what is the skewness of this? If you are getting positive 1, that's fine, it's fine, no issues. Little bit skewed, that is positively skewed, but yeah, it's fine, it's not too much skewed. See, I have already taught what is the skewness called. See, those who are new to this video, in short I'll show you what is skewness. If we have a data, most of the data is present between this, but your data is right now skewed, means if it is positively skewed, it will be more likely to this way. If it is negatively skewed, it is more likely to be this way. And if it is normalized, then your data will be more likely this way, right? So this is the point of the positive skewed. If it is around over here, like 4, 6 something, then it will be more likely this way. If it is 1, okay. If it is 0, it will be normally distributed. If it is negative 4, negative 1, it will be apart from the mean, right? That is skewness. Okay, handling outliers. See, right now I Okay, I'll run this. And I have one more file, that is this one. Better I use this Netflix, because I have already done EDA on this part. See, what does it says? He reads CSV Netflix. So we have a data, titles of data of the Netflix, in which we have cast. Okay, who have cast in that particular movie. Like it's a movie or TV show. It's a movie or TV show. Right now I'm getting two values. And what is the title, blood, and water? Which category it is belong to? Like what is the description? It is listed in international TV shows, dramas, mysteries, right? Release year, what was the release year, what is the duration? So okay, we found the info part. Then we go for the describe. We found the mean of the release year. Release year of the mean is this one. Okay, till now from 1990. Also I have already done that. Then what is the minimum value? Yeah, 1925. From 1925 what till 2040, what is the maximum? 2021. From 1925 we have the values from year 1925 to 2021. The mean and maximum value, maximum of the movies were produced in 2014, and minimum of the value is 1925. 25 percentile of the movie has been produced in 2015 13, sorry. 75% of the movies between 1925 and 2021 is in 2019. Okay, then we found the null. How many nulls are there? So definitely in the director list many are null. If we can find some of them, yeah, see, nan, this is the director list only, nan. So we have around 2000. Over here you can also see 6117. There are a lot of null values over here also. So we got the df.isnull.sum. So we got the sum. Duplicated sum, no, there is no duplicated row. Then what is the value count of the director? How many different directors are there? So we can say 4528 rows and one column, means 4528 different directors are there, right? That's a great number. Then after df rating, we found for the what are the value counts, or what are the different ratings we have? So TV MA, TV 14, TV RG, and what is the how many countings we got for that? 3207. Like out of 10,000 of the data sets, 8,000 of the data set, we have 3,207 ratings of TVMA, right? Then if you want to which country has the maximum count, value count means it will give you the count of how many times it has appeared. See over here, the country is United States, South Africa. Which country has published this show or that TV, right? TV show or movie. So yes, very different. So United States have published 2,818 movies or TV shows total, and India has published 972, UK 419, UAE Jordan is 1 on the Netflix. Then release year dot value counts. Okay, how many pictures were released or movies were released in 2018? That is 1147. In 2020, 953. In 2019, 1030. See, this is sorted according to this value, right? If you want release year to be sorted, put sorted df.release year, sorted, then dot value count. Then it will give you in the sorted way. Right, see 1961, then 47, then 66. Then we have df release year dot value counts, get 2019, means in 2019 how many values are see over here we can also get, but let's say it's not visible for 2014. So you just change the value of get 2019 to 2014. You'll get a value of how many movies are released in the year 2014, right? Then I created a dummy variable, movies. Dummy variable, no, it's good to say a variable, not a dummy variable. Movie 2019 we created, in which we have the movies released in 2019 and whose type is movie. It's not a TV show. As we saw, there are movie and TV show, but I want all the movies which are released in 2019. Give me that only. Okay. Then give me its title and rating so that I can better choose for myself which movie I have to watch. Then I printed a state using fstring. Total movie released in 2019. The length of the movies were, you can see movies 2019. Okay, 633. Total movie release were 633. What were the title and rating? Paradise Hills, TVMA. 5 Feet Apart, PG-13. The Spy Who Fell to Earth is TVMA. So yeah. Then PD type dot value count. Type means again how many movies are there? 6131. How many TV shows are there? 2676. Now I wanted that. Okay, give me the value count of listed in, which are movies. For example, we'll go check the listed column, right? Listed in documentaries, and which are movies, like the values which are present in listed in, which belongs to type movie. These are 57, right? If I check for the documentaries, I want to watch documentary only, then I went to the listed in column, and in which the if the string is containing documentaries, case is equal to false and n is equal to false is just for your this what we say uppercase lowercase, and n is again null and all. Documentary titles is equal to documentary, then title we are appending the list to the documentary list, and to list, yeah. Then printf total documentaries, length of the documentary, how many total documentaries it found. Again, we got 869 documentaries. These are the documentaries name. Why it's like this? Because we converted into the list form. That's why. Then filtered movies is equal to okay, if I want to check for the movies like which are in the duration, let's say 30-40 minutes, or over here I have passed 300 minutes. Oh, okay, over here I got error, huh? No, it's answer only. See, filter movies, I want key those movies which are having watch time, or let's say duration more than 300 minutes. So what I have done, okay, I went to the duration part. In that, if I'm checking for the string which contains minute, why minute? Because there we saw there are seasons also, right? So to avoid that season, I went for the string which contains minute. N is equal to false. Then filtered movies duration int. Again, I am creating a duration int type of value in which filter movies. Now filter movies duration string extract d plus as type integer, converting into the integer, nothing else. Short movies, filter movie, yeah, short movies. No, I changed it. You can change it to anything. Let's say 90 minutes or 30 minutes, 40 minutes. You can put and or all also. So that's up to you. Filter movie duration, and I passed the title and description. Just printed the total movies under 100 minutes. What was the length? So 4523 movies. Like you can change 100 to 300. Just I change the code from 40, 100 and 300. Right now it's 100. No, I'll put 100 only. Greater than 100. Okay. Let's go for the next. Indian TV show df country dot string content India, case is equal to false and false. Same thing, just it's about analysis, how much analysis you're doing. India TV shows is not defined. Okay, over here it's shows not s. Okay. Indian TV shows df dot country. Now it will run because this is not defined. Let's connect this now. We'll run again. We'll get some values. I'll show you what is the difference now. The point is I should have that Netflix titles. I think so. I don't have. Okay, no issues. Today I'm making a lot of mess, but okay. Definitely this need to be run now. Okay, in the next video, or this will be covered by Anirudh then. See, this is my last video. After this, Anirudh will be taking the charge. He will be giving you the feature engineering, and I'll tell him to cover this part also. Okay, or else definitely when you do the feature engineering or you will make the projects, you will get to know okay, what are these values. So this is a little bit of a high level of data analysis, but I'll explain the codes. Right, let's say there is a question, is Netflix investing more in recent content or reviving old classics? Definitely you can plot of this, plot release year, KDE, that is already told you. Color beans, see again it's needed, I don't have that data set, or I'll download it. Netflix dataset. Yeah, this one only. Click on upload, go down, check for the Netflix. Yes, Netflix upload. Yeah, I'll just click the copy path. I'll update the path if in case it's get misplaced or something. And yeah, we are ready to go. I'll run now. Runtime, run all. Now I got the values. Hmm. Is more in recent content or reviving old classics. So what I called his plot in Seaborn library only, and KD is true. That is K density is nothing but this line you are seeing. No, it is the density estimation part, and this is the title. What I did, okay, I plotted the release year. Okay, with the count again, count is automatically taken. Okay, how many counts are there? See, in the 1940 it's very less, but in the 2020 the count went above 3,500. Right, so you can see ki earlier it was not reviving that part. Right now it's just printing the not printing creating new part new movies. Okay, just read the code. It's the same release year, Netflix content release trend. It's the same thing, nothing else. Okay, there is a one more library known as plotpy is there. No, okay, I would have included, I think so. How there is a library called as word cloud, right? And word cloud is there, one more is there. So word cloud is nothing but your the favorite thing which comes on the before. Okay, I'll talk about this plot figure size is this pie chart. If you want to draw, okay, how many movies are there and how many TV shows are there, just call auto PCT is nothing but auto percentage up to 1 point only. If you change it to 2, it will get you to 2. I'll show you. Change it to 2, put shift enter, you'll get up to 2 decimal places, 62%. Now colors is nothing but red and blue. If you want to change it for whole FFFF, put it shift enter, I think so that is for black, sorry white. Yeah, this is for the white. You got this as the white. Okay, so change it to some 5733 was there. No, change 5733 to 3346. Let's say some unique color we will get. Okay, I'll change to 9. Yeah, okay. Wedge pros width is 0.4, nothing this width. And if you want, okay, how much radius is there? So I think so it's not defined, so it is taking automatically. Okay, after this, yeah, word cloud is there. In this word cloud, what happens? No, this is the way we use word cloud. Means the more TV shows and movies are having, international movies are having more data, like more number of rows with the same column, then it will come at the top. TV dramas are less, then see what are the different types of movies. Sci-fi is less, Korean TV is less, but family movies, comedies, kids, independent dramas, independent, international TV, international movies, dramas. So it will come like this is a word cloud, a fancy way to represent the numbers of the genres which has come over here. See, I'm generating the genres. Width and height is nothing but your width and the height. Background color black, or if you want pink or green, you can pass green. Look at the background color as green. Let it connect to the change runtime type. Not green. Let's say blue. DF is not defined. Okay. See, I changed my run type from the normal CPU to GPU. No, that's why it's giving DF is not defined. Okay. Again, you have to upload it. Okay, we'll go for the till it's changing its runtime. Okay, next I think so the question is this: K, how many movies are there? See, my next question was after this. Okay, see, this is the bar plot of the top 10 director with the most content. See, we can see the Ravi Chaika, right? And palette is the plasma palette. Palette means okay, the color which I'm using. See, the color is changing from dark purple to yellowish. So this is a palette. And right now over here I changed from black to blue, so I'm getting as a blue. Here, right, plot figure size, then top directors, value count of the head, that is 10. Like I got the value count. I'll go from the maximum to the minimum, and in that I counted for the 10. Right, if I want 5 only, it top 5, I have to change over here 5 and just put shift enter. I'll get for the 5. See. Okay, import plotly.express. Yeah, this is also a good one. Instead of Matplotlib, you can go for this also. This is a good one which helps. See, right now if you have noticed that there is no emoji. Whenever I have used emoji, this is absent. But in the Plotly, you can easily put anything, and the color and the graph, you can actually zoom it. If you want to zoom it like this, you can zoom, double click to zoom out. Yeah, here also it's popped. If you want to save this, you can save it, and a number of things are there. So it's open source, you can use. Again, a histogram I release year, color type, group. Same thing, Netflix growth by year. Again, I here defined the pie chart with a radius. A hole is 0.4. If I change to 0.3, see, there will be a difference of the size of this hole. If I put 0. See, for the 3, 4, it's not a big one. Put it to 7, 0.7. See. Then movie and TV show, you got color type. Which content dominate Netflix content? Guess. So, if you have any guess, better. Otherwise, use this. Top 10 countries, I again value count got the head value. See, this is EDA, no? You can't have directly approach, okay, this is the only one way approach. You can have n number of approach, you can have n number of analysis. So, it's up to you how you're going to deal with it. Then we have bar chart, fixed.px.bar chart, top countries.values, top countries.index. I'm giving in the y-axis. Orientation is horizontal. If you put vertical, it will go in verticals. Do like this. It will be orientation will be the vertical, but it is not visible. That's why I had changed it to horizontal. Okay, something fishy it's happening. Top 10 countries with most Netflix content. So United States has the most Netflix content, around 2,818, and India is at second position. Right. What is the most common rating category on the Netflix? Easy one. The common rating is, I just plotted okay types of rating and count. See, we have a 2 types, that is movie and TV shows, right? For the movie and TV shows, I gave okay, replace unknown ratings, count it, and for the path, clean one, check for the ratings and the type, that is stream map, values dot count, and just plot it. So in the movies we got, in the TV show we got, and here I have used Plotly, that is PX. Are Netflix movies getting longer? If yes, so how we can check? If plot this no box plot of duration, you will get the outliers. If yes, definitely. See, df duration integer dot string extract d plus as type float fix px. Okay, here only no box plot. I'm giving the movie name, duration, and I'm plotting it. See, the duration is the maximum movie duration is the 312 minutes. Another is 273. Right. So if I want to check what are the duration of the movie which are greater than 200, I can directly do like this way. And I printed okay, what is the duration of the movie which are greater than 200? If I want greater than 300, as we saw at 312 minutes. So yeah, we got one movie that is known as Black Mirror Bandersnatch. Let's check this data set is correct or not. movie duration 1 or 30 minutes, so that is wrong. Or I think so another one 2 or 3 minutes. Okay, leave it. So this is just you can say a wrong data set, but okay. So this was from the my end, else more files are there. Over here you can see. Okay, in my drive I'll show you. Okay, this is your internship folder. These guys are active. Okay, I was not going to show this, but okay. Drive, my drive, data. Okay, EDA. In EDA, no, check this one. Categorical numerical analysis IPYNV file. Okay, it will open. And let's say right now we're outlier is one, there is outlier. Yeah, outliers IPYNV. These are the files. I'll share the folder link only directly. Okay, in the description. See, everything is there, dataset info, and this is the categorical numerical analysis. How many numerical values are there? How many exited people of the France, Spain, Germany? How many of they are exited? That is one. This yellow one, though, who have stayed. Bivariate analysis. Okay, in the geography, female and male. You can read it by yourself. It's not making sense if I am reading. See, if positive one is there, positive correlation. If negative one is there, negative correlation is near to 0, it's no relation. For example, over here 1 is the correlation, that is credit score with credit score, but 0.05840, it's making no sense with the row number. It's a customer age with balance. Let's say check age with balance, that is 0.030. What is the most correlation factor with the age? And yeah, see, this is the exited value, 0.28. I think so this is the maximum value. Yes, so 0.28 is the most correlated feature with the age and exited. Means I'll show you. See, exited, then age. This is the heat map. Over here, where is the age and where is the exited? See, it is coming into around this. So the 0.28 was there to 24 something. So that's why it's in the range. This is the color palette, not palette, we can say color scale in which it is plotted. See, for the one, it's dark brown. For you can easily use for to check the relation between the data. See, the dark greens are nothing but the less correlated, so you can skip. Zero correlation, you can easily skip. Again, if it is somewhere minus 0.2 or something, so these are highly correlated, means number of product with balance with number of products. And again, same thing. And telco based data, see over here, we are sorting the index of the data set what we have for the age column. So we got okay, this much people are there. This is the KDE plot. Again, to under chart, what is a light chart is there. Try to do this, you will get to see, codes are very easy to understand. If I'm going to teach each and every line of the code, that doesn't make any sense. 3 sigma technique is nothing but you just I should teach I have already taught in the EDA too. 3 sigma technique is pass a function. Over here we have passed a function. Yeah, see, we have set the upper limit, that is mu plus 3 sigma and mu minus 3 sigma. And if the values are greater than upper limit or less than lower limit, then this will come into the list of the anomalies. We'll append over there in the outlier and we'll definitely return it. And we have calling it over here. Then how many outliers are there? 461. Okay, read the functions by yourself. You'll get to know. This is the KDE plot. See, it is a left side, no? It is positively skewed, right? If you want to make it normalized, do the logarithmic of the data. I'll show you. If you do the logarithmic of the data, it will be it will become less skewed, right? This is the box plot to check outliers. Yeah, so percentile concept is also given, what I taught in the second class. So as you can see, churn modeling, handling missing values is also there, how you can handle the missing values. So go through these IPYNV files and let us know if you have any doubt. Have 54 missing values, how we can say, because in the gender 54 missing values are there, in this 300 missing values are there. ओके, इजनॉल डॉट सम भी करा हमने, तो हमें जेंडर में 54 मिला, एज में 300 मिला, राइट. सो दिस इज़ वन ऑफ द वे you can say. Okay, this is for the today's class. I'll end and my session ends here only. There will be no video from my side in this internship. If you guys have any doubt or if you want me to repeat any concept, do let me know in the WhatsApp. Okay, thank you for your time and enjoy the video. Yeah, your certificates will be given in the next week, right? And let's check how many people watch this video. If you have watched this video, put a message me, hi, I have watched your video. And right now I'll write a code. You have to write that code in that WhatsApp message or something like this. Okay, this is the code you should put in the WhatsApp message while if you have watched the video. Okay, that's how I'll come to know, or send me the screenshot of this screen. Okay, thank you guys, have a great day.